In 1997, nobody had ever studied salmon rearing in a salt marsh by that time in Oregon, which is pretty stunning. Nobody had even bothered to look up until that time. It took till 97 when we started at Salmon River. So it was the first place that work ever even began. It still remains, I believe, the only place to quantify the contribution of a restored estuarine wetland to the returns of adult salmon. So in terms of salmon, the interesting thing about salmon and estuaries is that for most of my early career, for all of my early career, they were pretty irrelevant to salmon, because the feeling was that really the goal for salmon, the conceptual framework under which fish biologists worked, had to do with producing more fish for harvest and recreational use. And that all seemed to be, the thought was that all occurred in fresh water when the fish were very vulnerable at the smallest stages, eggs in the gravel. And that's what led to the real interest in hatcheries going back to the turn of the century. And that mindset is what made people have or not have any interest in estuaries to begin with. When they did finally have an interest in estuaries, it was because of the concern that they were a bottleneck to production, that survival wasn't going to be good in them because all the fish from this watershed had to go through this little space. And so the feeling was that predation was a big problem, or competition was a big problem. And so when we did start studying estuaries in the 70s, it was all about what's the carrying capacity of an estuary, how many fish can you stuff in it before it becomes a problem. In the 1980s, we even tried barging fish offshore of the Columbia to see if we could get better survival by circumventing the estuary altogether. We'd already circumvented the early life history by rearing them in hatcheries, right, and taking them out of the river. This was going to go ahead and take those fish further out offshore before we released them. The point is that there was a conceptual bias as to why we did or didn't think about estuaries. That is the reason why we didn't bother to go look at salt marshes until 1997. Today, we're spending millions of dollars in the Columbia River. In fact, it has been, up until the recent court decision, has been an integral part of the whole salmon recovery program in the Columbia Basin, is the restoration of habitats in that estuary. So what I'm going to talk about today is how do we get from the estuary being basically a problem we had to resolve, either by getting rid of predators or reducing competition or rearing the fish so they could avoid it, to being a really important rearing area that is integral to actually restoring and recovering salmon. That's a pretty dramatic shift in a short period of time. And I want to, talk both about our results and place it in the context of a different conceptual framework that I think is what this is leading to, and in part it was driven by. So some of the first work that was done on Chinook salmon that began to look at the life history of salmon and began to recognize that estuaries might indeed be important was work that Paul Reimers did down on the Sixes River, a tiny system down there by Cape Blanco, smaller even than Salmon River. And what Paul found in that one tiny system was contrary to this sort of general diagram of when we think of salmon life history, what they do. What he found was that there were 5 different kinds of rearing types within that one tiny population. Some of the fish left immediately after they emerged from the gravel and went straight to the ocean. Not many, but some. Some of them reared in fresh water and then went to the ocean in their first year of life. Some of them spent a whole year in fresh water and then went straight to the ocean. And then a couple other types dropped down in the estuary at different times, some in the early summer, some in the late summer, stayed for weeks or months, grew to a larger size, and then went to the ocean. And the interesting thing was that Paul found that this type, even though it was not at all the most abundant of those types, was by far had the highest survival. The fish that went the latest, stayed the longest, and left at the largest size contributed the most to the adults coming back. And he inferred that based on reading scale patterns, which he had been able to do in great detail in that particular river, to be able to distinguish estuary rearing from freshwater rearing in those fish based on their scales. Now, the point that I want to make here is not that estuaries are the critical part of their life cycle. The point is there isn't a critical point. They're all critical. If they want to go out, go from their headwater stream out to the ocean. They got to go through the estuary. They also need to be able to emerge from the gravel. They can die anywhere along this circle, but they got to make the whole circle to come back, right? So it's a huge pathway out into the ocean and back, and the estuary is just one part of that life cycle. But Paul found that they use that estuary in very different ways within a single population. So the concept that is emerging, and you may have read or heard in recent years, they've been referring to it as the portfolio effect, is the notion that it's like your personal stock portfolios. Salmon hedge their bets by not putting all their eggs literally into one basket. They basically do a whole lot of different stuff to spread risk in time and in space, so that if something destroys one part of their habitat, say at the upper part of the basin, you still got fish doing something else. They're somewhere else at that time, and they're not affected by it. Same thing goes in Salmon River. If you've got all of your habitat in the estuary has been diked, that if they were going to use that kind of habitat as an alternative rearing habitat, that option's not available to them. So the point is that when you have a high diversity of life histories, these different patterns, these different pathways that juveniles take to complete their life cycle, if you have a whole diversity of different life history pathways that fish can take, that allows them to dampen that environmental variability as a population as a whole. They're not all equally vulnerable, okay? But if you start losing that diversity, then their ability to dampen that variation is impaired. And so the key to that, though, is that all of those variations are directly tied to the habitat. Their ability to express what their genome will allow them to do in terms of these alternatives really depends on the rearing habitat to be in the system so they can express that. They can't express an estuary rearing life history if the whole estuary is diked. They can't spend a whole year in freshwater if the freshwater habitat is bad. And so the point is that life history expression and the diversity that is key to their production, and I would say their resilience to variation in the natural environment, is that they have intact habitats along that whole pathways to enable this full expression of what their genome would otherwise allow them. If we build it, do they come, do they use the habitat once you take the dikes out, and do they do it right away? And if they come, do they derive some benefit from it? And those benefits we were thinking of were things like, how long do they stay? Do they feed while they're there? And are they deriving some growth? Because those are kind of surrogates for how they might perform later. And it was only later that we got to the ultimate question, and that was, if those juveniles do come and they do benefit, does it matter? Do we get better survival? Do we get higher diversity? What is contributing to the adults coming back? Did any of the adults coming back actually depend upon that estuary, or was that sort of irrelevant to which individuals made it back to spawn? So the main take home was that fish use it fairly soon after restoration, and that position along the tidal gradient and access into the marsh still are important factors independent of just the individual restoration age of recovery. And you can see that these fish really aren't coming into the estuary until fairly late. This is what it looks like since all the restoration had occurred, those three marshes that I was talking about, the 78, the 87, and the 96. Look at how much more rearing we're getting in the spring, March, starting as early as March or April, and certainly by April, May, and June, that we were not seeing at all before. We think that's a direct response to habitat that wasn't available to them before, and the juveniles are showing up and being in the estuary. Those are fish that are directly linked to those estuary marshes, because that's where we find those fry rearing. Those small fry are rearing in those off-channel habitats. This is a direct link between the restoration of those marshes and the adults coming back. And sure enough, a big portion of these also includes up to 75% of the spawners were ones that had reared in the estuary more than 30 days. So a big portion of this group would also include fish that had come in the early part of the summer prior to when they were showing up before. The point to make here is that those same four life history types are all showing up, including these guys here that were not present at all before, and at least half or so of these guys probably were contributing to the adult spawners. So not only did those juvenile life histories get expressed by virtue of coming down and rearing in the estuary, they survived. They survived and came back as adults. And those are real fish that would not have been contributing to the adult population because they had no access to do that before.